Hey everyone, ever hit save or post in an app and just wonder what happens next? I mean, really, what's going on behind the screen? Today, we're going to follow a single piece of data on its wild two-part journey through a modern microservices application.
For us, it's just a simple tap. But that one little action, it kicks off this incredible chain reaction. It's pinging databases, cloud services, all sorts of processing engines. So to really get a handle on how this all works, we've got to ask the big question. In an app today, where does our data actually go? To make this journey real, we need a hero. So let's meet the star of our show today, the AdventureTube data object. Pretty much everything inside the AdventureTube app, every feature, every function, it all revolves around this one critical piece of information.
So, what is this thing, really? Well, at its heart, it's a rich geospatial record. You can think of it as the digital glue that connects a YouTube video with all its chapters and info to actual real-world places on a map. And that connection, that's what makes the whole AdventureTube app even possible. Okay, so if we peek under the hood at the object itself, we see some stuff you'd expect, right? A YouTube ID, arrays for places, and chapters. But I want you to focus on that owner email field. It looks so simple, but trust me, that little field is the key that unlocks the first, much more complicated journey we're about to follow. And right here, this is the core idea of this entire explainer. This one single data object, it follows two completely different paths inside the system. The journey it takes when it's being created is a world away from the journey it takes when someone's just trying to read it. And this slide just lays it out perfectly. On one side, you've got these secure, authenticated writes. Think of it as a careful, deliberate, scenic route. And on the other side, fast, public reads, a direct, no-nonsense superhighway for data. We're talking two totally different goals, which means we need two very, very different paths. All right, let's trace path one, the secure creation journey. We're going to follow our data object from the moment a user creates it all the way into the database, where things like security and ownership are absolutely critical. Okay, let's walk through this. First, the app sends a secure token, a JWT, which is kind of like a digital passport. Then the auth service checks that passport to make sure you are who you say you are and that you actually own this content. Now here's the clever part. In step 3, the data isn't saved directly. Nope, it gets published to Apache Kafka. That's a messaging system that makes sure the data won't get lost, even if other parts of the system are swamped. And while all that's happening in the background, the app is getting these little status updates so the user sees progress instead of just staring at a loading spinner. Finally, a dedicated geospatial service grabs the data from Kafka and saves it for real. And check this out, this is one of those real-time updates I was just talking about. It's this tiny snippet of JSON, a server-sent event, basically telling the app, yep, we verified ownership, we're moving on to the next step. It gives you a little window into that complex background process. How cool is that? Okay, now let's completely flip the script. What happens when someone just wants to look at the data? This is where path 2, the public retrieval journey, comes in, and its one and only job is to be fast. I mean, just look at how much simpler this is. The client makes a public request, the gateway just zips it over to a lightweight web service, which then talks directly to the geospatial service. That service just grabs the data straight from the database and sends it all back. There's no Kafka, no complex authentication, it's just a straight shot to the data. And the result of that super streamlined path? Pure speed. This number comes directly from the system's own performance tracing. To get all 39 of those documents, the entire round trip, from the user's tap to the data appearing on screen, takes just 471 milliseconds. That is less than half a second. Blink and you miss it. And if we break that time down, you can see exactly where every millisecond goes. The key thing to notice is that the heaviest part of the lift, at 241 milliseconds, is the geospatial service and the database query itself. The other services are just lightning-fast relays getting the request to where it needs to go. So we have these two completely different journeys. And this wasn't an accident, It was a very deliberate architectural choice. Which brings up the big question, why? Why go to all the trouble of building two separate paths for the exact same piece of data? Well, this table really just lays it all out. The secure write path is all about data integrity and ownership. It uses robust tools like authentication and asynchronous messaging to make sure everything is perfect. But the public read path, it's built for one thing, pure speed and availability, so it uses direct calls and gets to skip all that overhead. By separating them, you don't have to compromise. You get rock-solid security where you need it, and you get incredible speed where that's what matters. It's the best of both worlds.
And that really brings us to the big takeaway here. This pattern, this idea of separating the path for writing data from the path for reading it, it's incredibly powerful. It lets you build systems that are both super secure and blazing fast, without having to sacrifice one for the other. So it leaves us with one final question for you to think about. How might this principle impact the way you design your own systems? Thanks for joining me on this data journey today.